before we solve with problems, remember, if you have to convert from radian to degree, always use the conversion, or even degree to radian, always use the conversion. Pi radian is equal to 180 degree. Okay, this is the first formula. And if you have to calculate the length of the arc or area of the sector, then length of the arc is L is equal to R theta, and area of the sector is A is equal to half R square theta. So these are the three formulas what we'll be using in solving the problems in this particular video. Let's start with the first type of problem. See here, convert into radian. So it's given in terms of degree, you have to convert to radian. All right. What did I just tell? You always have to use the formula pi radian is equal to 180 degree, correct? Or 1 degree is equal to pi by 180 radian, correct? This is more like a general formula which you guys have to remember, or you can just derive it. It hardly takes 10 seconds to do it anyway. All right. So the first one, 500 degree. So this becomes 500 into pi by 180. So you need not have to completely divide and get in terms of decimal. It makes no sense. Now 50 by 18, this you can do. You can write it as 225 times to 9 times. So you can write it as 25 pi by 9 radian. This is the answer for the first one. Very simple. Let's do the second problem. See the second one, we have minus 45 degree 30 minutes. Okay, now it's in terms of degree and minutes. Now to solve these type of problems, listen carefully. To solve these kind of problems, convert that minute into degree. Okay, so get the degree in the fractional form, not in terms of decimal. Fair enough? In the sense, see, this is nothing but 45.5 degree, correct? 45.5 is nothing but 45 degree 30 minutes. So this we can write it as minus 45.5 degree. Okay. So 45.5, this you have to convert into fraction. Now you can do it in two ways. One, you can write it as 455 divided by 10. You can simplify it. This is one way. Or the other way is 45 1 by 2, which you can write it as 91 by 2. I mean, it's pretty much the same anyway. Okay, so this we can write it as 45 and half. Of course, there's a negative sign. This is going to become a minus 91 by 2 degree. So this you are converting to radian. Alright, you are going to get minus 91 by 2 into pi by 180. Now if you look at it, 91 and 180, the 91 will not cancel 180, correct? And you can't do anything here. So the final answer what you can write is minus 91 pi divided by 360 radian. This is the answer for the second one. Okay, now let's do the third one, the last one, 470 degree. We'll finish this one. See, for the third one, what you have, 470 degree. So this becomes 470 into pi by 180. Cancel the 0 and 0. 47, I think 47 is a prime number. So you can't do anything. 47 pi by 18 radian. See, this is going to be the answer for the third one. So we have converted all the degree measure into radian measure. Now we'll do the other way around. Okay, that means we'll convert the radian into degree measure. So we'll do that in the next part of the same video. All right. This part we are converting it into degree. Again, the same conversion. That means you have pi radian is equal to 180 degree. So 1 radian is equal to 180 divided by pi degree. So we'll use this one. Okay, so here we need to multiply by 180 by pi. Okay, so we are going to use this one. What is required? Alright, let's look at the first one. Very simple. You have 12 by 5 radian. Remember, I was telling you that you have to take, the any real number can be a radian. This is one of those cases, where you are taking example. Now here, since the degree measure, whatever we are taking, see, degree will be in terms of degree, minutes, seconds, these kind of things, correct? Now you can take pi as 22 by 7. Generally, degree is not kept in terms of pi, if you have noticed in all the cases, right? That's why you can take pi as 22 by 7 and you can do the calculation, all right? So here we have 12 by 5 radian. So this is going to become 12 by 5 into 180 divided by pi. 22 divided by 7, or the 7 goes to numerator, correct? Now, so you can do by 2, 2 6 times, 2 11 times, then 5, 5 3 times 15, 36. So you have 6 into 36 into 7 divided by 11. You can't really divide because 11 is a prime number and nothing cancels out here anyway. Now we have to multiply and divide by 11 to get the answer. Of course, you are going to get in terms of decimal. So what we'll do, we'll take two decimal places and take degree and minutes. Okay, this is how we need to solve it. Fair enough. So let's divide, multiply, and let's divide this one here. 6 into 36 is 216 into 7 divided by 11. Alright. The answer for this is going to be 137.454545. It's basically it's recurring. Now what you do, keep the 137 separately. That means you can take this as 137 degree and 0.45 degree. Okay, again I'm telling you 0.45 degree. Okay, so 0.45 degree we can convert in terms of minutes. See, 1 degree is how many minutes? 1 degree is equal to 60 minutes. Correct? So 0.45 degree will be what? 0.45 into 60. Correct? So we can write this as 137 degree. And you know what? I'll just do the calculation here. So 0.45 into 60. So that's 4.5 into 6. 6 into 5 is 30, then 27. So 27. That means here you will get 137 degree and 27 minutes. Let's not go for seconds, guys. I mean, you can if you want. I mean, because it's 0.454545. You can take up to seconds also, which is going to be a little more accurate. But here we are not looking at that much of accuracy. So take just two decimal places, cut into minutes. This is the answer for the first question, which is 137 degree 27 minutes. Fair enough? Now let's do the second question. For the second one, you have 3 pi by 5. 3 pi by 5 radian. So this we can write it as 3 pi by 5 into 180 divided by pi. Pi and pi cancels out. Very easy. 5 36 times. So 3 into 36. 3 into 36 will give you 108 degree. So answer for the second one is 108 degree. Very, very simple. Right. Now let's do the third one, minus 3.5 radian. The third one here, minus 3.5. Now what I would suggest for you guys is pause the video, solve it. See, it's exactly the same as the first one, correct? First one is in fraction, this one is in decimal. That's the only difference. I want you guys to solve the third one on your own. Pause, solve it. Later on, you guys can just look into the answer and the method how to solve it. I hope you guys have solved it. Let's solve this one now. So here, minus 3.5, I'll write it as minus 7 by 2. Okay, minus 7 by 2 into 180 divided by pi. So 290 times. Correct? So minus 7 into 90 divided by pi, which is 22. 7 goes to numerator, isn't it? 2 you can do 45 times, 11 times. Now you have minus 49 into 45 divided by 11. Correct? So now if you do this one, you will get the answer as 200.4545 recurring. Keeps on going. Do the same logic. Take the 200. So we can write this as 200 degree 0.45 degree. Again, we have to convert the degree into minutes. So what again, the same logic. So 0.45 degree. So this we can write this as this into 60. Correct? So this is going to become 4.5 into 6, which is going to give us 27.0. So you will get 200 degree and 27 minutes. This is the answer for the third question. So here we converted radian into degree. In the previous case, we converted degree to radian. Correct? Remember, for conversion from degree to radian measure, you can keep the pi as it is. But when they ask you convert from radian to degree, always keep in terms of degree and minutes. Fair enough? Now let's do the third type of problem. Third type is where we use L is equal to R theta, A is equal to half R square theta. Okay, this is the third type of problem. Let's solve the third type now. Look at the first question. A wheel makes 360 revolutions in 1 minute. Through how many radians does it turn in 1 second? Okay, now you need to understand in 1 minute it's making 360 revolutions. Is what we call as RPM, revolutions per minute. Now what we'll do, we'll convert the 360 RPM into how many RPS. RPS is revolution per second. Alright, so let's do the first one now. Now what we have the number of revolutions per minute is equal to 360. Correct? Or you can say 360 RPM. Minute if it is 360, that means in 60 seconds. So let's do unitary method, okay? So for 60 seconds, it is doing 360 revolutions. So for 1 second, it's going to become 360 divided by 60, correct? Which is 6 times. So 6 revolutions per second. So in 1 second. See, one revolution is nothing but one full circumference, correct? So what we can tell is that one revolution is equal to one circumference. One circumference is how much? 2 pi r, correct? Isn't it? So now here, one circumference is 1 2 pi r. Or can we also say that one circumference is nothing but 2 pi radian? Correct? So one revolution is nothing but 2 pi radian. Now this is making 6 revolutions in 1 second. The total angle 6 into 2 pi, which is 12 pi. Did you guys understand? Again, I'll repeat it here. They're saying it's 360 revolutions per minute. Correct? So that means in 1 second, it's going to be 360 by 60, which is going to give us 6 revolutions per second. Right? Now, one revolution is nothing but from here to here. That's one full revolution, which is nothing but one circumference. One circumference is how many radian? 2 pi radian. So one revolution is 2 pi radian. Like that, it's making 6 revolutions in 1 second. That means in total, so what are we going to have? So one revolution is 2 pi radian. Therefore, for 6 revolutions per second, so what will be the answer? It's going to be 12 pi radian. 6 into 2 pi, isn't it? So 12 pi radian. This is the answer for the first question. Fair enough? Now let's do the second question. See, what do we have? Theta is equal to 100 degree. Radius is 14 centimeter. Find the length of the arc and corresponding area of the sector. Convert that 100 degree into radian. This is the first step. Okay. So what do we do? Theta is equal to 100 into pi by 180. Cancel, cancel. 5 times 9 times. So we have 5 pi by 9 radian. Correct? Now we can use the formula L is equal to R theta. So what do you have? L is equal to 14 into 5 pi by 9. Can use 14 into 5, 22 by 7 into 9. Twice, I don't think so we can do anything. So this will be 220 by 9. Correct? So 220 by 9 will give you 24.44 centimeter because the radius is in centimeter now. See, this is going to be the answer for the first part. Correct? Now what we'll do? Now we'll start with the second part, area of the sector. Half r square theta. Okay, we'll do that one. A is equal to half r square theta. So in this case, this is going to become half 14 into 14 into 5 pi by 9. So you can have, this is 7 times 7 into 14 into 5 by 9 into 22 by 7. 7 and 7 cancels. So what do we have now? 14 into 110 divided by 9. Correct? This is going to give us the answer. So 14 into 110 divided by 9. The answer will be 71.11 centimeters square. Got it? This is going to be the answer for the second one. Alright. Now let's do the third one, the last problem here. Circle has a diameter of 40. So radius is what? 20. Radius is 20 centimeter. The length of the chord is also 20. Find the length of the minor arc of the chord. So what we'll do, so we'll write one small circle here, as a reference figure. Now you have a radius. So let's say we are going to have a radius something like this. Let's say this is the diameter. Okay. The length of the chord is also 20. Correct. Alright. So being this as the radius, let's say we are going to write a chord something like this, which is 20. And from here to here, this is also 20. This will also be 20. Correct. Find the length. So what is the central angle? 20, 20, 20. Don't you think it's an equilateral triangle? Correct. So here we can say OAB. So triangle OAB is equilateral. Since this is equilateral, theta is going to be 60 degree or 60 into pi by 180, which is going to be pi by 3 radian. Isn't it? Since this is pi by 3, now we use L is equal to r theta. 20 into pi by 3, or we can just write it as 20 pi by 3. That's okay. 20 pi by 3 centimeter. So this is the answer for this given question, because they're asking you find the length of the minor arc of this chord, isn't it? So basically they're asking you the arc length AB. Fair enough? Now, these are the three types of problems what you have. Okay, three types. One is conversion of radian to degree, degree to radian 2. Then this is the third type. Alright. So this particular video has all the three types of problems. Please go through this again and again so that you understand how to do the problems. Alright. So in the next video, we'll start with trigonometry basics.